Good afternoon. This is tips for workshop questions of assignment 3, questions B1 to B3. So B1 is on the screen. There are 3 functions given. First two of x, y, and z. Top left there. Third one, function of x and y. You have to find the 1, 2, for 1, 2, 3 of B1 is step 1 is find the, or derive rather the, instead of find, first order conditions. So for 1 and 2, that means you calculate df dx, set it to 0, calculate df dy, set it to 0, calculate df dz, set it to 0. Give them names A, B, C. Step 2 is solve the FOCs. So for 3, it's a function of x and y only, so it's df dx is 0, df dy is 0. Call this A, call this B. So in step 2, you solve these first order conditions to get one or more stationary points. Now in case in function 1 is except for the 2 is quadratic, so the vector 2, the 2 at the end, the number 2 is not going to do anything. So it disappears when you take the first order conditions, the factor of 2. So you will have the origin as stationary point only. The second and third functions are higher order functions. So you expect, not necessary, but you expect more than one stationary point after solving the FOCs. And then once you have found the stationary points, in step 3 you calculate, derive the Hessian. So don't look at A. I would in all cases calculate the Hessian. Of course, for the function in 1 you could write down the matrix A, but let's just in all cases derive the Hessian. For the first function, the Hessian has only constants as components, and for the second and third function, the Hessian will be a function of it will be a function of x, y, z, or at least a subset thereof, but it's not a matrix with constants. Then you evaluate at each stationary point. Then the Hessian consists of components which are constants because you've evaluated at the stationary point, and then you use the PMT to classify. So this was asked, right? Classify, or it might be indefinite as well, right? Classify the stationary points. So that's what you need to do for question 1. Oh, it just not working. Right, there we are. In B2, you're given a quadratic form. So let's B to A, you are given a quadratic form, Q of x and y. Step 1 is write down the corresponding matrix A. Question is, then you calculate the determinant of A minus lambda I is 0. That gives you the eigenvalues lambda. So you will have a lambda 1 and lambda 2 because this Q is a function of x and y. Then you can characterize Q. Q based on the signs of lambda 1, lambda 2. And you check that with the PMT by using the principal minor test on the matrix A. Then you find the unit eigenvectors by solving the eigenvector equation. So you solve V is lambda I V, and then take care that V in the end needs to have unit length by normalizing properly, and then you transform to new variables x1 tilde, x2 tilde, and then you verify that Q x1 tilde, x2 tilde, which is lambda 1 x1 tilde squared plus lambda 2 x2 tilde squared, that when you find the expressions express x1 tilde and x2 tilde in terms of x1 and x2, that you find the original quadratic form. So the x, this is then x and this is y. So x1 tilde or x tilde is the eigenvector v1, well, let's say u1 times x vector, and likewise x2 tilde is y tilde is u2, the unit eigenvector, times x vector. So this is the tilde. So that's how you calculate the relationship between the new tilde variables and the old x and y variables. So in the that doesn't help. So you take x1 tilde is x tilde is unit eigenvector inner product with x vector, and x2 tilde is y tilde is u2, the eigenvector times x vector. So in B we have a quadratic form, but now one with 3 variables, and we do the same thing. We find the eigenvalues characterize Q. Basically it's the same question, but you have matters in you analyze matters in with 3 variables. So it's the same, but for a case with 3 variables, which means more work, quite a bit more work. So solving the eigenvector problem is a bit more advanced. It's lambda is 0, lambda is -7, and lambda is -21. So it's a negative semi-definite case, etc. So B3 oh, what am I doing now? B3A, railway company sells tickets. B3A. So we need to write down the profit function. Everything here is expressed in terms of Q1, Q2. So that will be the revenue minus the cost. So the revenue will be P1, Q1. So price P1, Q1 items for the economy for first class plus prices, I suppose, for economy class times the amount of tickets Q2 minus the cost as given. And the whole, since we're given P1 and P2 in terms of Q2, this becomes then an entire function of Q1, Q2. Then we need to find the first order conditions. So now it's P Q1, which is the pi dQ1 is 0. Likewise, PQ2 is 0. Then you solve these. And you find Q1 star, Q2 star, the stationary points. Since it's a quadratic, it will be only one stationary point. And if you have, once you have Q1 star and Q1 star and Q1 star and Q2 star, you can find P1 star and P2 star as well, because you can rework the given relationships to express P1 in terms of Q1. Then you need to derive the Hessian and evaluate at the critical point, right? Q1 star, Q2 star, and then use the PMT to get a classification to see whether it's a maximum, and subsequently you need to determine whether the total profit pi is positive or negative, is a profit or a loss, and then draw a conclusion whether you need to suppress the cost. The B3B is a similar way. It's a theater company now. It's actually a similar question. B3B, we express everything in terms of now the request is to express everything in terms of P1, P2. So then you rewrite well, Q1 is already written in terms of P1, so now R minus C is P1 Q1, and U plus P2 Q2 minus C of Q1 Q2. But given the expression for Q1 Q2, you can express everything in terms of P1 comma P2. Then you write down the first order conditions. So now is the Py. The P1 is pi P1 sub P1, pi sub P2 is 0. You solve, then you get P1 star, P2 star, and since the cost is a function of as a given constant in it, you can calculate the profit at P1 star, P2 star, and then set that to 0, and then you can solve for K to get the break-even point, break-even value of K. So that tells you something how you would have to deal with the cost. So that's it for the first 3 workshop questions. Good luck with the questions.